Hello everyone. In this video we're going to be solving a radical equation. We have the square root of 4 minus x squared equals x over 2x plus root 3. And we're going to be solving for x values. Now, let's take a look at this equation. We do have a radical on the left hand side, and on the right hand side we have a rational function. At the end of the video, or towards the end, we're going to look at a graph which kind of explains the solutions we find. We're also going to be looking at the solutions that come from Wolfram Alpha for this type of equation. All right, great. So let's go ahead and take a look. Since we have a square root on the left-hand side, it makes sense if we square both sides, doesn't it? Let's go ahead and square both sides. When we square both sides, we're going to get 4 minus x squared on the left-hand side. And on the right-hand side, we're going to get x squared for the numerator. And for the denominator, we should be getting 4x squared plus 4 root 3x plus 3, square root of 3 squared, right? And then if you cross multiply, you should be getting 16x squared plus 16 root 3x plus 12 minus 4x to the fourth power minus 4 root 3x cubed minus 3x squared, and the whole thing is equal to x squared. Now, since we have a negative x to the fourth, let's go ahead and put everything on the right-hand side. 4x to the fourth power, and then we do have an x cubed term, which is that. So we're going to be plus 4 root 3 x cubed. And then let's go ahead and collect all the x squares together. 16 minus 3 is going to give us 13x squared. And if you subtract it from 1x squared, that's going to give you negative 12x squared. So that takes care of all the x squared terms. And then we're going to subtract this, minus 16 root 3x. And finally, we're going to be subtracting the 12. And notice that everything is divisible by 4, so you can go ahead and divide everything by 4. X to the fourth power plus root 3x cubed minus 3x squared minus 4 root 3x minus 3 equals 0. So this gives you a quartic equation, and obviously solving this problem is going to be kind of fun, kind of complicated. You can use the quartic formula, which is, again, quite complicated. Or you could probably, I'm not exactly sure how this works, but you could do a change of parameters here. I haven't tried it. That's why I'm not exactly sure. But this looks like an appropriate method. You can go ahead and call this a. Then this will be a squared, and this will be 4a. And then you can kind of turn this into a quadratic in a and try to solve it that way. I'm not sure again, but you can go ahead and try it. That's going to be a fun method. So this is kind of like an initial look at the problem. Obviously, you don't want to deal with the quartic. Let's go ahead and do this differently. So here's what I'm going to do. Let's start with the original problem. We have the square root of 4 minus x squared equals x divided by 2x plus root 3. Great. Now, this problem is actually kind of like a special type of problem where we can use a special type of substitution. Let's see how that works. The only issue we have with the domain is we have to make sure that 2x plus root 3 does not equal 0, which means x should not equal negative root 3 over 2. And by the way, that kind of gives you a clue that should about the type of substitution we're going to use. And on the left-hand side, we have a radical. So let's go ahead and look at what's inside. 4 minus x squared should be greater than or equal to 0. And this just means that x squared must be less than or equal to 4. If you square root both sides with the absolute value, you should be getting the following. X must be between negative 2 and positive 2 inclusive. So what does that tell you? If you got something like this, it will be nice. X is between negative 1 and 1. Then we could use a trigonometric substitution because, as you know, sine and cosine are in that interval, right? But we can still do it just by doing a little bit of trick. So the trick we're going to use is called division by 2. Let's divide everything by 2, which is kind of easy to do, right? And now we got what we need. So now x over 2 is between negative 1 and 1 inclusive, which means we can set it equal to a trigonometric sine or cosine function. Which one should we use? I'm going to use sine alpha in this case, and you could probably use cosine. It wouldn't matter. So from here, since we set x over 2 equal to sine alpha, and by the way, that doesn't violate any other part, because the only thing we need to worry about is, x does not equal negative root 3 over 2, so we have to make sure that our expression doesn't give us that. And besides that, we don't really have any limitations. So from here we get x equals 2 sine alpha, right? That's what we're going to plug into our equation. And when we do that, a lot of interesting things are going to happen. Let's go ahead and check it out. So replace x with 2 sine alpha, 4 minus 4 sine squared alpha, and then equals 2 sine alpha divided by 2 times x, which is 4 sine alpha, plus root 3. Awesome. This equation looks kind of confusing, but notice that we can simplify this using an identity. Take out a 4, you get 1 minus sine squared. Hopefully you've done a little bit of trigonometry and you recognize this 1 minus sine squared is the same as cosine squared. So this gives us the square root of 4 cosine squared alpha, which can be written as plus minus 2 cosine alpha, right? You could also use absolute value, but let's go ahead and do the following. Let me show you how this proceeds with the positive case, and then the negative case is going to be very similar. Let's go ahead and take the positive value, 2 cosine alpha, and not necessarily the positive value, the one with the plus sign, because cosine alpha could be negative, couldn't it? So we're going to get 2 cosine alpha equals, on the right hand side we have 2 sine alpha divided by 4 sine alpha plus root 3, and immediately, hopefully you see this, we can cancel out the 2's. We can divide both sides by 2 and get rid of those. Now we can go ahead and cross multiply. 4 sine alpha cosine alpha plus root 3 cosine alpha equals sine alpha. Now again, this equation is also a special type. You'll see in a little bit why. One of the things that I want you to recognize is 2 sine alpha cosine alpha is the double angle for sine. So I'm going to go ahead and subtract root 3 cosine alpha from both sides and write this as 2 sine 2 alpha. All right? Great. Now let's go ahead and use another common trick for this. Square root of 3 can be written as tangent pi over 3. Isn't that cool? Okay, but tangent pi over 3 can also be written as sine pi over 3 over cosine pi over 3. Again, this is a trick that we often use in trigonometry. Like some people could be a little surprised, like where does this come from? It's commonly used. Now let's go ahead and look at the value of cosine pi over 3. That is cosine 60 degrees, which is 1/2. So this is going to bring you a 1/2 at the bottom, which means that's going to bring a 2 here, right? So we're going to get something like 2 sine pi over 3 cosine. But let's not replace it with 1/2, because what we would like to do next is actually going to be more fun to do. Let's go ahead and do it. So we're going to get, let's multiply by cosine pi over 3. So we get the following: sine alpha cosine, I should probably write it as a fraction, sine alpha times cosine pi over 3 minus sine pi over 3 times cosine alpha over cosine pi over 3, which is 1/2. Now, I'll show you how that cancels out, but let's go ahead and move this a little bit so it doesn't cut off like this. So let's go ahead and put it here. It's going to look nicer. Now, we're going to do the following. Cosine pi over 3 is 1/2. When you multiply these, you're going to get 1. Now, the left-hand side is sine 2 alpha, and the right-hand side, notice that is a formula for a difference formula. Sine alpha cosine beta minus sine beta cosine alpha, and that is equal to sine alpha minus beta. Make sense? Hopefully you know these formulas. So in other words, the right hand side is equivalent to sine alpha minus pi over 3. Now we got a simple trigonometric equation. We can solve this like 2 alpha equals alpha minus pi over 3 plus 2n pi. Put the alphas on the same side. Alpha equals negative pi over 3 plus 2n pi. And of course, there are other solutions that you need to consider. We could also do for sine, we can subtract this from pi, because first and second quadrant, remember that. And then we're going to get something like this. And then from here, if you put everything on the same side, you're going to get 3 alpha equals 4 pi over 3 plus 2k pi. And after division by 3, you're going to get alpha equals 4 pi over 9 plus 2k pi over 3. And by changing the values of k is an integer, you can get different solutions. Okay, you get the idea? So this is going to give us quite an interesting solution. One of the solutions obviously is going to be 80 degrees, but this is just alpha, and what we're looking for is x. X is equal to 2 sine alpha, so in this case x is going to be, I made it like alpha. X is going to be 2 times sine 4 pi over 9. Makes sense? That's just one of the solutions. Let's go and look at the solutions for Wolfram alpha. It's expressed like these. And the graph of these two functions, a semicircle and a rational function intersecting at 3 different points. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.